Our next guest is Mesut Güneş. Mesut began his career as a software developer in 2007. He became interested in test automation and DevOps from 2010 onwards, with the goal of automating the development process. He is passionate about open source tools and has spent many years providing test automation consultancy services and speaking at events such as this one. Mesut Güneş, he's here for From Chaos to Clarity, ML-powered continuous performance testing. We are thrilled to have you here, Mesut. Hello.
Thank you. Thank you for a nice introduction, and thank you for having me here. So the question is, if you are running the performance testing continuously, then there is a big issue that you will handle the evaluation of the results very carefully. So today's talk is From Chaos to Clarity, Machine Learning Powered Continuous Performance Testing. And my name is Mesut. Mesut Güneş from Turkey. And I'm working as a senior principal consultant at Modus Create. Modus Create is a fully remote company, and it is a consultancy company. So we have clients from all over the world. So you can find me from the internet with these nicks and IDs, and also you can connect with me in the with the LinkedIn. And basically, I'm an automation engineer at Modus and providing automation solution for different clients from different sectors like health, e-commerce, automation, and different sectors. So let me ask who you are. If you can answer one of these questions, yes. For example, if you are a tester, I believe most of the guys are testers, or if even you can be developers or performance engineers, or maybe once a time you did a performance testing, you can find something very interesting in these slides. So let's continue with the table of contents. So basically, the title is From Chaos to Clarity and Continuous Performance Testing and Machine Learning. So we will focus on what is continuous performance testing in the beginning. And we need to understand the performance testing and continuous performance testing. Then we will show how we can collect the data to evaluate the performance testing results, which is running continuously in the pipeline. And there is a problem. And the main idea of the presentation is basically about this, the evaluation of the performance testing results. And there are some methods that you can use for the evaluation. And I'll show you how it can be applied basically. And I'll also deep dive into the use of the machine learning or artificial intelligence to evaluate the models. And there will be also demo. And at the last but not least, we will talk about the benefits of the continuous performance testing and machine learning models for evaluation. Okay, so let's quickly continue with the next step, next pages. So what is continuous performance testing? Basically, you see that this is a traditional and maybe well-known testing pyramids, and it shows that there are a couple of levels in our in the software development lifecycle. And the performance testing is testing the non-functionality of the system in terms of functionality, right? So we are checking some functional requirements in terms of non-functionality, like we can measure the response time, the amount of the user that can use the system, and so on. So basically, the continuous performance testing is a concept that is designing the performance testing to run in the pipeline, and the test can be run automatically, and the evaluation of the results should be automatically. And we will use different toolings and different scripts, different languages. So it is a part of the CI/CD pipeline, the continuous performance testing, I mean, and you will get both shift left and shift right approaches. So from the testing environment, we are mostly discussing with the what is it? I mean, it classified the test in terms of the levels of the software development lifecycle. Like in the unit level, we will run the unit test, right? And when we go beyond of the unit level, then there is an integration level, which means that the units are integrated into a system, and then we now use the integration level for the rest of the whole backend and other APIs and everything. So that is called integration. And for the integration level, we are mostly running the integration tests, and these are the mostly the functional tests. And at the E2E or the user acceptance level, we are running the E2E test. I mean, end to end from one beginning of the journey, we will continue with the end of the journey. So which is called E2E test. All of them are functional tests, but most of the time we are just forgetting that there is also non-functional test. The performance testing is one of them, and this is something adapted to the test environment. And you can see that there is also a lot of different non-functional tests. Each can be run for each level. So I'm saying that this is the continuous testing, and it is the performance test. So which means that we can run it at every level of the software development lifecycle. I think this is very critical to understand the rest of the presentation. So in the unit level, so we can run unit test as a functional test, as I said, but at the non-functional side, we can also run load testing, maybe security, code coverage. These can be easily adapted to your pipeline. So maybe you can imagine that the developer just implemented a new algorithm, maybe new method, and to test the performance of the algorithm, you can just run maybe in a loop 100 times, maybe 1,000 or million times, then you can see the performance of the algorithm. So this is kind of performance testing, right? At the unit level. So when you come to the integration level, you can also run load or stress test because there is an environment and there is an integration. So when you call a simple API, then it goes through all the microservices, maybe the services, and then it returns back a result. So which is kind of integrating all the part of the system. And when you come to the E2E or the user acceptance test, there is E2E test as a functional. But when I come to the non-functional part, then again you can repeat the E2E test for the performance testing. So, for example, the user can sign up and then sign in and then select product and then go to the basket and then maybe complete the checkout. So you'll test the whole system in an E2E test level, but this time we are just checking if you can repeat this test under a heavy load. So you can repeat the load testing, stress testing, spike, endurance, scalability test, all kind of tests at the user acceptance level. So basically the continuous performance testing can be applied for any level of software development lifecycle. It can be at the unit level, integration level, or user acceptance level. So basically when I come to the performance of a system, so you'll see that it is kind of perceptual, which means that when you are testing some not mission critical things or just using some, let's say, leisure activity, then it is maybe the response time of the system might not be so good, but you are still happy. But maybe you can imagine that you are just using some promotions and then also using some critical things. And when you come to the checkout step in a e-commerce company, then you are just under stress because maybe it is not successfully done. So you just see that the performance should be good enough, or maybe you are just playing a game and the response time from the server side servers should be good enough to mimic everything on your client. I mean, gamepad, anything. So it is really perceptual. So which means that for the continuous performance testing, when you are testing a system, and if you want to evaluate the result of the system, then you should have some metrics, and that should be defined specifically for your systems. So let's go then. So when we talk about the test pyramid and all the things about the levels and the testing types, and we can easily say that there are a lot of different kind of application of the continuous performance testings, and I'm just presenting one of them. For example, the strategy can be like this. The continuous performance testing is just running in the integration testing level in the pipeline to check if everything is running smoothly and okay. For example, you can see that there are two microservices in .squared, and there is a performance test at the end of the pipeline in the service one build pipeline. So there is the similar things happen on the service two as well. So you can see that this is kinda integration level testing. So because we just compile the code and then deploy it into some test environment, and we run it. We run an integration testing on the integration environment, and then at the last step, maybe the performance testing as a non-functional test. So when you come to the full picture, when you check the system under test, you will see that a lot of services in there. Those can be microservices. So this can be called as an user acceptance testing. And we can also run the test against the user acceptance testing. So which means that we are running the performance testing at the user acceptance level. So this is good. So whatever strategy you have, so you have to define all the things, depends on your needs. So the strategy is it's a basic thing that everyone can understand the same thing with the performance testing. So when a developer just commit a code and then want to check the results, then he should see that there is a performance testing steps and it can be failed. Okay, let's go to the strategy and the levels. So we can apply the continuous performance testing for every steps with a different type of performance testing. I didn't mention much about the performance testing types, but basically we have load testing, stress testing, spike testing, endurance testings, soak testings. So all of them can be a good candidate for the automatedly run continuous performance testing. But there is one which is very good and which can be easily applied for the continuous performance testing, which is the load testing. Basically the load testing is just you can specify the load. I mean, the definition of the load testing is just testing the system under a nominal load, which means that when you go to the live or the production environment, it is an average amount of the user that you get from the production side. So which means that there is an specific load levels, and also you know that there is a specific metrics. These metrics can be gathered from the business side as well as maybe the technical side as well. So basically we have some predefined metrics. So with these predefined metrics, we can evaluate the results. So which means that the evaluation part is kind of tricky part, because when we run the test in an environment and we want to test the same test in a different environment, then it can produce different result. So the result cannot be comparable. So to be able to compare the testing results with the historical data, or let's say the previous run, to be sure that it is the same, I mean, comparatively same at least. So we should be using always the same environment, or identically same environment. Automated load testing is also needing some script knowledge. For example, you can use some testing tools like K6, Gatlinks, Locus, JMeter, whatever performance testing tools you use. You need to script some part to make it automated. Because in the CI pipeline, we want to run just one script to run whole performance testing, and we can go to the next steps for the evaluation part. So basically, the automated load testing is a good candidate for the CI/CD pipeline because there are a lot of things are controlled. Let's go to the next slide, which is collecting the data. Basically, collecting data is an important step because there are two kinds of data that we need to handle during the evaluation part. The first one is the current state of the current results of the performance tests, and the second one, the data that we need to need to use for the evaluation. So whenever we create a data should have some characteristic, like the data should be clean and it should be presentative. I mean, for example, for the performance testing, we should have a clear identical data like response time, median response time, or average response time, whatever. So maybe we should also use the amount of the users. Maybe define, for example, if we want to test the system with the 1K user, maybe 1 million user, that should be defined. And as a data, we should create those data. So the data should be comparable, which means that every time we should collect the same kind of data. I mean, the data can be changed, but the how to say, all the keys should be the same. For example, the response time, the number of users, number of RPS data, whatever it is. So it should be good enough, not much, not less, because we don't want to collect so much data that cannot be handled or that cannot be representative. Or let's say if it is so much, but we cannot use all of them because the data is kind of clustered differently. So just to know that we should have some data, and it should not much, not less. And we are just running the continuous performance testing. So it is a process, right? So there is also data processing, and the process is just starting with the running the test. For one of the demo in this presentation, I'm just using CSV data. So whenever I run a test, the results should be saved as a CSV data. And when the test completed and the data is collected, then I need to evaluate the results, if it is satisfied or not. Let's say if it is satisfied, then I can go to the preparation of the data. If that is okay, then I can say that there are some data should be removed, then I can remove it. And after that, if everything is passing, then I should update the data, the historical data. If it is failed, then which means that it is failed. I need to run again. Let's go with the evaluation problem. So basically, you have already run the test and see the results, but you are not sure how can you evaluate the results. There are different kind of evaluation, and the test result itself says a lot of things. I mean, it should be beyond the passing or failing, because passing is just saying that it is passed, but how was good the data, the results, and how can we do for the next iteration, next run? So if it has failed again, we need to know that why it has failed deeply. I mean, for one response, or maybe running different tests in a different occurrence, then maybe cause a problem. So the data is very important. As I said, the previous page, data is the king. So we are just building an algorithm and the hypothesis all on the data, and so the failing and the passing and the evaluation is very critical for the continuous performance testing. All we know that the test should be autonomously completed, which means that it should be run automatically and the evaluation should be automatic. And then if there is a failure, or let's say the passing, then it should give a good report. And there are different kind of evaluation methods. The first one is using the threshold data, or let's say the static data. Some kind of tools are embeddedly providing some threshold value. For example, this is a K6 script. K6 is one of the well-known and the very famous performance testing tools. It is good because the internal performance of the K6 is very good, and it provides very descriptive API. So you can use it easily. If you don't know the K6, you can maybe you can run it in maybe in 5 minutes. It is that easy. The K6 script is written in JavaScript, but the backend is the Golang. So you can see the static data from here. For example, there are some options we are just adding to the scripts. So VUS, which is the number of the virtual users, is 1000, 1K, and the duration is 30 seconds, which means that this test is running 30 seconds. After 30 seconds, it stops and try to evaluate the test result with the threshold data. Threshold data is kind of, let's say the average should be less than 20 milliseconds. The description is kind of wrong, but the average less than 20 milliseconds, and the P9 on the percentile 90, which means that the 90% of the test result, the performance of the 90% of the test results should be less than 30 milliseconds. Similarly, the P95 should be less than 35 milliseconds, and max of the response should be less than 50 seconds. So this is good. I mean, you can, if you have an idea about the metrics, then you can apply these methods. But there is a problem about the static data. The environment is itself evaluated, which means that the code is always getting new features, maybe getting new features that is affecting the overall performance. So using the static method is not good for that case. So which means that the product itself is a live object, but the evaluation cannot be static. This is good, but it is not enough. The second evaluation method is using the statistical approaches, which is using the normal distribution. Basically, the normal distribution, when you have a good enough data, your data can behave normally distributed. So which means that for the performance testing, if we have enough data that we collected from the earlier runs, then the distribution should be normal. So the picture is showing that if you want to cover the testing results, for example, with the 95 percentiles, you should use the 2 standard deviation, which means that in the middle there is a median. But if you go to the 2 cycles, which means that you are just you are just covering the 95 percentile. So basically, the normal distribution can be used for checking the results with the normal distributed data. So let's say you have previous run and want to use the want to check the current results. So you can check that if the current result is behaving or the similar with the current data. This can be a null hypothesis, and there's also alternative hypothesis that the current matrix is not good enough, and the difference is very significant. And this is one of the things. It is still kind of static because our data is the evaluation is always on the same standard deviation. And the third one is using the artificial intelligence or machine learning for the evaluation. Let me check the time. So basically, what is machine learning? Machine learning is a subset of the artificial intelligence that is a system that can learn from your data, also identify the patterns, and finally, it can create a decision, make a decision. So the machine learning models are based on the data that you just provided it. And basically, the machine learning is kind of using some artificial intelligence libraries, and then it uses the data to create an algorithm. And when it creates an algorithm, and it can identify the patterns. So finally, you can use it for creating a decision. For example, you have historical data, which is good, and you know that all the historical data, all the performance testing results in the history are passing. And now you have new run, and now you have new, new test results. So with the machine learning models, you can just try to understand your current result is similarly, or let's say it is very same with the historical data. So machine learning is also a process. So you can imagine that there's a baby, and baby doesn't know an animal, and how to learn the animals to the babies. And it is very similar to machine learning models. So you can show a dog to babies and then understand that it is kind of creature that he can understand, she can understand. Or so basically the machine learning model is the same, or the machine learning process is the same. So you have to collect the data, and then the models should be process the data, and then eventually we choose the correct models, and which means that there are a lot of different machine learning models, but which one is the correct one for your cases? So when you choose the models, let's say it can be anything, and we have to train the model. With the training models, the data is just training the models to make a decision based on your own data. So, but this is not enough. So which means that we have to identify the success of the model. So the next step is just evaluating the success of the model. So let's say training can use 8% of your data, but evaluation can use 20% of your data. So after the evaluation, you can make some optimization, and finally, then you can deploy your model to use your new data. Also, For the performance testing, I mean the artificial intelligence or machine learning powered performance testing evaluation, it is also a process that we have to run. For example, we have to run the the performance test, to create new data, and then process the current and the historical data. For example, we get new test results, and also we have the historical test data, right? So we have to train the models, and then after training, we can use the different machine learning models. For this example, I want to run the anomaly detection. It's one step that you can identify if there is an anomaly in your system, in your test results. So after that, you can run the regression analysis. It is again a different machine learning models. And the final one is the trend analysis. I think I should go faster. So let's go with the models. The first one is the first one you need to know is that the model is not itself is good enough. So you have to train it. For example, you can use the 80% of your data to training the model, and then after that, if you are sure that training is okay, then you can use the 20% of your data for testing it if it is good enough. If it is not good enough, then you should change the model, or you just need to optimize your model. You can see the steps from here. For example, for this one, we are just using random forest regressor. So we are just splitting the data into training and testing, and then just using 80% for the training, and then 20% for the testing. And the first analysis, first evaluation, is the anomaly detection. Anomaly means that, for example, you have a lot of tests run on the one environment, and then you get the test results. And it shows that normally you're expecting that the average of the response time, let's say 100 milliseconds, but there is one request that is around 2K, 2 seconds, let's say. It is too much, right? It is kind of outlier. So we have to identify these kind of things. If there is kind of outliers, then this anomaly detection can detect it easily. So there are different kind of approaches for using the anomaly detection. You can also use the statistical methods, which is not a machine learning or AI. But in our case, we are using the machine learnings and AI. So there are 3 different categories that you can use. The supervised can be used for the labeled data. If it is labeled, then you can use semi-supervised or supervised model, both. If it is not labeled, then you can use clustering. But in our case, it is it is labeled. So the second one is the regression analysis. The regression means that your current test result, how can it is similar to the previous one or the historical one, which means that there is a dependent variable and independent variable. The dependent variable is the one that just we are testing, and the independent one something different.
Masoud, you have 5 minutes left. Sorry.
Oh, that's great. Okay, I can go faster. So for the regression analysis, we are just using the random forest. And the third one is, as I said, the trend analysis. The trend analysis means that maybe your test result doesn't have any anomalies, and also there is no regressions. But maybe there is a little trend that goes up, and this trend cannot be catch in the previous analysis. So the trend analysis is kind of this one. So sometimes when you see that the test result is very, very similar to the previous one, but it is always going up. So trend analysis is something that can detect this kind of trends. So let's go to the demo. If I can do it. Okay, can you see? I think it is visible. This is demo time. It is pretty simple. I'll show you one positive and one negative case. Basically, this is the repo. Also, you can reach from the GitHub. Basically, it is a very simple microservices system. So we are testing the dog register. Basically, this is the dog app. Dog is simple animal, so you can play with it. You can walk with him, whatever. You can also register to sleep it, whatever. So this is the dog register that we are testing today. And when you, okay, so this is a simple example of the, yeah, there's a merge request, and then when you have a commit, it runs all the tests. So this is a simple pipeline. So as I said, I'm running the test on the integration level. Maybe you can see it easily. So the unit testing at the unit level is okay, and the contract testing is okay. So, and then I'm just moving on to the performance testing. I run the performance test, and I collected all the data. I have the historical data. Then I can start the analysis. It starts from an anomaly detection, and then regression analysis, and then trend analysis. If everything is okay, then okay. So I can update the historical data with the current data because I know this is something very good in terms of performance, and I can add it to the historical data for the next iteration. So if we check the data, it is something like this. We have time step, we have average time, minimum time, median time, and maximum time. Also P90 and P95. This is the data. I am always expecting the data should be in this format. So, and this is the current data. This is the left one is the historical data, and the right one is the current data. I have the same format of data. You see timestamp, average, minimum, maximum, whatever on the left side. So I'm just going a little bit faster. Okay, this is one of the machine learning model analyzing the performance of the results in terms of the anomaly. So you can see that I'm just reading the historical data and reading the new data, and also scaling the data to be, it can be comparable, and then training the isolation forest model, which is using a machine learning model for the anomaly detection. And then I'm just getting the score. So you can access all of these code from the GitHub, and then you can check it. If you have any question, concern, want to learn more, you can ping me from anywhere from the social media. And this is also another one. This is just checking the regression analysis. Again, I am just reading the data and then training the model, and then also evaluating the results. Okay, so let me come to the, I think, this part. So just I have a commit, and then I just want to run the test. Then it is running the test, evaluate the results in the GitHub runner. It installs a lot of requirements, depends on the models, but it doesn't take too much time. Don't worry about this. This is the one of the tests. It is, this case, it is passing. It gives me some results. So this is the results. So you see, everything is in the green area. So there is no issues. And then this is the trend analysis, and there is no issues again. And the negative case. So you see that I am just adding microseconds. You see that just 20 microseconds. It is very small one, but you'll see the result that it is causing a failure. So I'm just pushing it with new commit, and it triggers a new build here. You can see the, all the checks here, and it runs the pipeline again. And you see that, this is the performance testing steps again. It is running, installing everything, and then checking the result. It installed the K6. I forget to say that I'm using the K6. And okay, I need to go faster, I guess. Yeah, it is failing finally. So let's check the results quickly. Yeah, this is the result. So you see that this is something, out of the range, right? It should be under this area, but let's say it is not something. Yes, you can see that the P90 or the median is okay, but average or the P95 is not okay. Similarly, there are some other results that is not passing like this. So basically, this is it. Let me return back to the presentation, and so basically, let's talk about the benefits. You are ready to run the performance testing, whatever you need. And the machine learning powered continuous performance testing gives you an idea about if your current result is specifically good enough for passing the next step. So it can create an awareness in the team as continuous performance testing runs for every commit, and your developers can be adapted to this new test. And if there is something that can, that can have an effect on the performance side, then he can do some rigorous algorithm and run tests in his local. So that's it basically. And then maybe, this is the reference that you can use, and you can also download the slides from here. If you have any question, I want to answer it right now.
Thank you so much, Masoud. We actually have a question from the audience. It says,
Okay.
what kind of performance tests you run for the individual microservices and for the whole system, and how you define what are the limits or gate numbers for your microservice performance tests?
Oh yeah, good question. Actually, this demo based on the integration level, but you can also run the test on the unit level as a microservice code test. For example, when you run the test, and is ended.
Oh, you can share again if push the share button.
Am I edible? Okay. Margaret, should I continue? I mean, I was answering a question.
Do you want to share a slide for the answer? Is that what you're trying to do?
No, it was just gone. I mean, I don't know what happened. Okay, let me start answering the question again.
Sure.
So basically, the for the microservice or the microservice or kind of unit test level testing, you can apply you can run the unit testings as part of the performance testing. So you can use any servers to run the test. So there won't be any difference between running the test on the unit level or on the integration level, but only the difference is the test, what you want to run the test. For example, there is an endpoint or there is a method that is providing a data, and you have just mock it. Maybe you can run a performance testing on that one. And I mean, when you run the test on the unit level, it might be more convenient than running on the integration level, because there is a different integrated part of the system that can maybe causing a problem. But the unit level testing is more convenient, and you will get always the same kind of results. Yeah.
Thank you so much, Mesut, for your thoughtful presentation and for us answering our questions. For the rest of the public, if any questions remain unanswered or you want to continue or make any other questions, you can contact the speaker throughout his LinkedIn. His profile is Güneş Mes. Okay, our team will leave it in the chat so you can see it. Thank you so much for sharing your experience with us and with this seminar, Mesut.
Thank you.
Thank you.